Today in this video I will discuss multiple operations on sets. So let A is a set of 1, 3, 5, 7, 9, 11. B is a set of 2, 4, 6, 8, 10. C is a set of 3, 2, 3, 5, 7, 11. And universal set is 1, 2, 3, dash, 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 15. That is all the natural numbers from 1, 2, 3 and up to 15. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the universal set. So suppose we have to find first A union B intersection C. So let's start. To find A union B intersection C, first we find the operation written within parentheses. So that means first we have to find out A union B. So A union B is the set. As you know, A union B is the set which contains all the elements of A and B, whether common or uncommon. So we have to see there is no element common between A and B, so we have to take all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the union of A and B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we have to take intersection of this A union B set with C. So write down A union B intersection C. So write first A union B. So write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 intersection C. C is 2, 3, 5, 7, 11. So as you see, the intersection of two sets is the set which contains all the common elements between the sets. So we have to see, we have to observe which elements are common between these two sets. So as you see, 2 is common, so 2, and 3 is common, we take 3, 5 is common, so we take 5, 7 is common, we take 7, and 11 is common, we take 11. So this is 2, 3, 5, 7, 11. If you observe, this is same as the set C. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. That means intersection of A union B, intersection of A union B with C is equal to C itself. So we may write it as C. So our result is A union B intersection C is equal to C. Now the next operation we have to carry out, this is A intersection B union C. So write it down, A intersection B union C. This is required. So first we have to find out A union intersection B. So A intersection B is equal to, as you see, A is the set of all the odd numbers from 1 to 11. So we take 1, 3, 1, 3, 5, 7, 9, 11, closed. Intersection B. Intersection B. B is the set of all the even numbers from 2 to 10. So set 2, 4, 6, 8, 10. So as you see, no odd number can be an even number and vice versa. So there may not be any common element between these two sets. These two sets are disjoint sets. Such sets are called disjoint sets. The sets which do not have any common element are said to be disjoint sets with respect to each other. So here A and B are disjoint sets. So the common element is nothing because no element is common between them. In this case we have to write down phi, that means null set. So A intersection B is a null set. Now we have to find out A intersection B union C. So A intersection B union C, write down the value of A intersection B we have found, that is null set union C. And what is C? As you see, C is 2, 3, 5, 7, 11. That means C is the set of all the prime numbers from 2 to 11. So write down 2, 3, 5, 7, 11. And as you know, the union is the set which contains the elements of both the sets. So if we take the union of phi and this set, obviously phi has no element in itself. So in union we have to take only the elements of this set. So we write down 2, 3, 5, 7, 11. So this is the value of A intersection B union C, which is the set C itself. So we may write it as C. So A intersection B union C is equal to C. Now we have to take A minus C union B. So first we have to find out A minus C. For that we write the set A as it is, because A is the set of all the odd numbers from 1 to 11. So we have written A as 1, 3, 5, 7, 9, 11 minus as it is, and C is the set of 2, 3, 5, 7, 11. So we have written 2, 3, 5, 7, 11. And as you know, A minus C is the set which contains all the elements of set A which are not in C. So we have to take all those elements of A which are not contained by the set C. So first we check first element of A. 1 is not there in C, so we have to take 1. 3 is there, we have to skip. 5 is there, we have to skip. 7 is there, we have to skip. 9 is not there in C, so we have to include 9 in this. And then next is 11, which is contained by C2, and we have to exclude it. So we have A minus C is equal to a set of 1 and 9. Now we have to take union of A minus C with B, because this is our required operation. So A minus C union B, we write the value of A minus C we have found in the previous step, the set of 1 and 9, union B, and B is the set of 2, 4, 6, 8, 10. So we have written union B 2, 4, 6, 8, 10. As you know, in the union we take all the elements of both the sets, provided no element should be repeated if it is common. So 1, 2, 4, 6, 8, 9, 10. We have taken all the elements of both the sets. This is the union of A minus C and B. Now the next operation we have to carry out is C minus A intersection B. So for that, first we have to find out C minus A. So C minus A is equal to, write down C as it is. C is the set of 2, 3, 5, 7, 11. 2, 3, 5, 7, 11 minus A. A is the set of 1, 3, 5, 7, 9, 11. So write down as it is 1, 3, 5, 7, 9, 11. Now C minus A is the set which contains all the elements of C which are not in A. So we have to check every element of C one by one whether it is contained by the set A or not. If it is contained by A, we have to exclude, and if it is not contained by A, we have to include. So the set first element is 2, which is not contained by C, which is not contained by A, so we have to take 2. 3 is contained by A, we have to leave it. 5 is contained by A, we have to skip. 7 is contained by A, we have to exclude 7. 11 is contained by A, we have to skip 11 too. So there is only one element in C which is not in A. So simply C minus A is the set of only one element, that is 2. Now we have to find C minus A intersection B. That means C minus A intersection B. So write down the value of C minus A, which is singleton set of 2, and intersection B, and B is the set of 2, 4, 6, 8, 10. Among these two, we have to take intersection of these two sets. So we have to observe which element is common between these two sets. Obviously, there is only one element in the first set which is common between the first and the second one. So only 2 is the common element between these two sets. We write 2 as it is. So that's it. This is the answer of C minus A intersection B. Now the next operation is A union B complement. So for that, first we have to find out A union B. So A union B, first write the elements of A, which are 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. And union B, and B is the set of 2, 4, 6, 10, 8, 10. 2, 4, 6, 8, 10. In the union, we take all the elements of both the sets, whether common or uncommon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have taken all the elements of A and B, and this is A union B. So now we have to find out A union B complement. A union B complement is the set of all the elements of universal set which are not in A union B by the definition. So we have to check the elements of universal set, that is psi, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the set which is universal set, which is denoted by psi. So we have to take all the elements of this set which are not contained by A union B. So obviously A union B contain all the elements from 1 to 11. So if we observe those elements of universal set which are not contained by this set, these elements are 12, 13, 14, 15. So the set 12, 13, 14 and 15. This is A union B complement. Now the next operation is B union C complement. B union C complement. So first we have to find out B union C. So let's find B union C. So B is the set of 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So write down 2, 4, 6, 8, 10 union C, and C is the set of 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. Now we have to take the union of these two sets, and in the union, as you know, we take all the elements of both the sets, common or uncommon, so provided no element is repeated. So 2, 3, 4, 5, 6, 7, 8, 10, 11. So this is B union C. Now we have to take B union C complement, which is the set of all the elements of universal set which are not contained in B union C. So as the universal set is the set of all the natural numbers from 1 to 15. So we have to exclude all these elements from B union C complement. We have to take each and every element of universal set which is not contained in B union C. So as you see, 1 is not contained in B union C. So we take 1, and after 1, all the elements from 2 to 11 are contained, except 9, sorry. 2, 3, 4, 5, 6, 7, 8 are contained, but 9 is not contained, so we have to take 9. 10, 11 are contained by B union C, so we have to exclude from the complement these two elements. After that, 12, 13, 14, 15 are not in B union C, we have to include in B union C complement. 12, 13, 14 and 15, and that's it. This is B union C complement. Now we have to find out the B intersection C complement. So B intersection C complement, let's find out B intersection C first. So as you see, the set B is 2, 4, 6, 8, 10, and the set C is the set of 2, 3, 5, 7, 11, and in the case of intersection we take only the common elements between the two sets. So as you see, there is only one element, that is 2, which is common among these two sets, these two elements of these two sets. So we have to take only 2. Rest of the elements are uncommon. So B intersection C is the set of 2 only, and now we have to take the complement of B intersection C complement, and as you know by the definition of the complement, B intersection C complement is the set of all the elements of a universal set which is not contained by B intersection C. So as you see, there is only one element in B intersection C, that is 2. So we have to exclude only element 2 in the elements of universal set. So we have to take all the elements of universal set except 2. So we have taken 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is the complement of B intersection C. Now the last operation, that is B minus C complement. So first we have to find out B minus C. So write down first the set B itself as it is, the set of 2, 4, 6, 8, 10, because this is the set B, 2, 4, 6, 8, 10, and minus C, and C is the set of 2, 3, 5, 7, 11. So 2, 3, 5, 7, 11. And as you know by the definition, B minus C is the set of all the elements of B which are not contained by C. So we have to check each and every element of B which is not contained by C. So 2 is contained by C, we have to exclude it. 4 is not contained by C, so we have to include it. 6 is not there in C, so we have to take. 8 is not there in C, we have to take 8, and 10 is also not contained by the set C, so we have to include 10 also. So B minus C is the set of 4, 6, 8, 10. Now we have to take the complement of B minus C. So B minus C complement is the set of all the elements of universal set which are not contained by B minus C. So as universal set is the set of all the natural numbers from 1 to 15. So out of these 15 natural numbers we have to exclude 4, 6, 8, 10. So B minus C complement is the set of 1, 2, 3, exclude 4, 5, exclude 6, 7, exclude 8, 9, exclude 10, 11, 12, 13, 14, 15. Then that's it. This is B minus C complement.